So good afternoon, I'm Chris O'Connell. I'm the Registrar of Motor Vehicles and the board member for New Brunswick. And I'm very pleased today to be the moderator of today's session. The presentation will last approximately an hour, and we've talked it over, and Gary's going to take questions during the session, so you don't have to save your questions to the end. The only thing that we ask is that you pose your questions using the microphone because the session is being recorded. And that's the only way that we can get your questions recorded for the purposes of the recording. Everybody good with that? So what you're here today for is a presentation called Ice Road Construction and Safety Training Program. So to discuss this topic with us today, we have Mr. Garry Snyder from the Government of Northwest Territories. So Garry has been the Government of Northwest Territories' foremost expert on ice road construction and safety for the last 10 years. Before that, Garry was at the Yellowknife Airport, and he was the head of maintenance and operations. So Garry has developed strong analytical skills to assess ice conditions and road safety trends and practices. And in his role with the Department of Transportation, Garry has been the lead on coordinating and finalizing data for all road construction in the territory. He also assists in coordinating training for all regions in the NWT when it comes to initial and recurrent safety training. Garry was born in Yellowknife, born and raised in Yellowknife, and has worked for the Department of Transportation for over 20 years. So I'm going to turn the floor over to Garry, and I understand he has two presentations, so he's going to get through the first one, and then time permitting, we'll get into the second one. So Garry.
Thank you, Chris. Appreciate that. I was going to brag about myself, but apparently I can't now because you told me everything there was to say. Welcome to Yellowknife, everyone. As Chris indicated, I've been with the department working on winter roads for a little bit over 10 years. All aspects of them, construction, maintenance, shutting them down, opening them up, those kind of things. Has anybody been, how many people in this room have been on a winter road or an ice road? So we have 1, 2, 3, 4, 5 of you. Of the 4 or 5 that are here, how many have been involved in construction or maintenance of a winter road? So as you can see, with a moderate amount of people in this room, there's not a lot of people that really are involved in construction and maintenance. There's a lot of us that go for drives on them. A lot of us may be semi-nervous about going for a ride on them, especially after ice road truckers, which most of us have seen and enjoyed watching. But in saying that, they are unique, and what a lot of people don't really recognize is their importance in accessing the communities, particularly the communities that don't have other access like ours does in the Northwest Territories, or certainly in the Deflection region where I work. They don't have barge access, right? So their access the rest of the year when the road's not open is small aircraft. Most of the runway strips are around 3,000 feet long, which are fine for the smaller aircraft, but not for the large cargo carrying machines, okay? So, the winter roads are roads of convenience for the public to travel back and forth on, but they're critical resupply for our communities, and that's our primary goal in the winter roads that we have. In saying that, here is a community of Windrows, which happens to be the furthest community from Yellowknife. To access the Talicha Winter Road network, we go down Highway 3 about 100 kilometers, and then it's another 300 kilometers to the community of Windrows Winter Road. Government of Northwest Territories operates and owns about 2,200 kilometers of all-season road, and we operate about 1,600 kilometers of winter road, minus the 190 kilometers in Inuvik to Tuk, which this year they'll hopefully open this fall. I think in November is the planned dates right now. So that section of the winter road will no longer be operational. But it just goes to show, the volume of winter roads that the Northwest Territories operates. Separate from government winter roads, in the territories we have some very popular, and ice road truckers was part of that, private winter roads. By far the largest and most expansive private winter road up here is the JV, or the Joint Venture Winter Road, which is a conglomerations of several mines that get together and operate the road as one entity, primarily for efficiency and safety reasons. They run off of our end of our Highway 4, which is about the beginning of the winter road, is about there, if you can see the red dot. about kilometer 69 on our all-season highway, and then run another up to 600 kilometers to the mine sites. Arguably, they're about the world's largest private winter road network, okay? Probably one of the most efficiently run winter road networks. And last year, just for stats items, they had about 9,000, just over 9,000 loads going northbound. So that's 18,000 plus trucks returning. Just some stats on that. What I forgot to mention when we started was this session is meant to be informal. So if there's any questions, if anybody has a thought or wants to speak up and say anything, absolutely more than willing to. The presentations I'm doing, like Chris had mentioned, are twofold. The safety part we're doing now is a little bit more dry, and then we'll get into the construction portion later, which we can skip through a little bit quicker and maybe a bit more entertaining for some of you. For the North Slave region, which I'm primarily responsible for, we have our primary roads are the Toledo winter roads. We've got about 465 kilometers of Toledo winter roads, which 60% are constructed over ice and 40% over land. Okay? And then separate from that, we've got a local road here just out of Yellowknife that goes across. You can see from here to there. It goes across to Deda. It's about 6.2 kilometers long. The reality is that's a road of convenience because there is an all-season road open to Deda all the time or year-round, which is about 22 clicks. But, you know, it takes 6.2 clicks. You run across the lake. It's relatively quick for the community. People can come home for lunch and for supper, back and forth, quite a bit easier. And it's very popular with the locals in Yellowknife and tourism. You know, anybody that comes up to Yellowknife in the winter, you know, one of the first ambitions they have is go down to the Deda Road. We have problems on the Deda Road every year. You know, it gets dark up here in the wintertime quite early, 3:30, 4 o'clock. We'll go down to the Deda Road. Our crews will go down in the morning or in the evening to do a road check, and we'll have Oriental tourists laying on the middle of the ice in the middle of a road that's active and running and operating in the dark with all their lights turned off. Why? Because the northern lights are brighter when it's dark. Right? So you see the northern lights really well, but when you have headlights come up to you, it's not so good, right? So as funny as it sounds, it's true. They you know, a lot of people don't really think of the safety aspect of that. And our crews, and you know, for the Deda Road, we construct and maintain ourselves, our own crews. So when we go down there with a heavy piece of equipment, a grader, or a plow truck, or even a vehicle to do a road check, you know, sometimes it's difficult to make them understand that you can't lay in the middle of the road. You got to go over to the side. We plowed that road 50 meters wide. There's a reason for that. You can stay on the side, right? But, yeah, no, it's just interesting things about, you know, you wouldn't normally see somebody laying in the middle of a highway, you know, the 401 or something looking at northern lights. But. Okay, so basically, our Toledo winter roads, they're crucial to the survival of the communities, okay? Each one of the communities we go to, Wati, Gamity, and Wikweti, and Betch goes off the main highway, you know, they're running anywhere between 300 and, say, 1,800 people population. When you take into account fuel, groceries, construction supplies, all those necessities of keeping a community alive and thriving, they need that access somehow. So for these communities, that's their only option to get the heavier equipment in, is the winter roads, okay? Winter roads obviously reduce cost of living in the communities, power, heat, fuel, groceries, and then general materials for themselves. And also, there's a socio-economic benefit, right? The Toledo land area and the Toledo communities, it's important for them to communicate with each other, to be able to travel from community to community. They have hand games, they go hunting, they have all the things that you and I take for granted, they don't until the winter roads open and they can travel them. So in saying that, we want to get back to ice road safety. And we've had, over the years, a couple of different versions of ice guides, or we'll call them training guides for our staff, okay? The previous version to this particular one was a 2007 guide. And as awful as it sounds, a lot of times these guides get updated or get implemented or revised when there's an incident or an accident of some kind. So the 2007 guide, the 2007 guide was, for argument's sake, a spin-off from an incident that we had where a snowcat went through the ice and the individual drowned, okay? When I come in over from airports to winter roads and we start working on them, what we noticed was that the guide that we have, which is our Bible for working on winter roads and doing construction and whatnot, didn't make a lot of sense in some of the things we were told to do or suggested to do in the guide. So consulting with our department and some ICE engineers and whatnot, we came up with a new guide. We call it version 2015. We actually didn't implement until 2016. It came out late in the year. But this guide was meant to be innovative in the fact that it would allow us to do our jobs while keeping us safe and deal with changing climate, changing weather patterns, okay? Having the ability, when we have extra controls and measures in place, to work on thinner ice than we could work on before. Our previous guide said, you know, here's the formula that we have for working on ice, and this is it, that's all, that's where you stay. So what was happening is, industry itself, we talked about the joint venture road a couple minutes ago, you know, they've had consultants and engineers and you know, they have substantially larger budget than we have to deal with winter roads. You know, we don't have a for-profit type scenario. So we have a flat budget and we're expected to construct and maintain our winter roads each year within that budget. So what we ended up doing was hiring a consultant that had done most of the work on the joint venture winter road to help us out construct a new guide for ourselves that makes sense, that allows us to put the controls and measures in place to do the same type of work that the private sector did, keeping ourselves, our employees, and the public safe. Does that make sense? Okay. So in saying that, we spent about 2 years putting this guide together, and there was a lot of discussion about what was appropriate and what wasn't appropriate, and what should be public and what shouldn't be public. And our deputy minister at the time, you know, finally stood up and said, you know what, we're government. What we do is public information. So we provide that information to our own staff, to our contractors, and to the public with in a framework that they can understand it and operate with it. But we have to provide them with what we do, not provide them only with what half we do. So that was sort of, you know, one of the highlights of this guide, I guess, to say that, is that everything we do is either in the guide or in the appendices that go with the guide, some of which are still being worked on. And those appendices will be worked on forever. Like, we finished the winter road construction season this year, we'll do a review, and we'll make some adjustments to our appendices. I should have pulled a guide out. Have anybody in this room actually seen the guide? So this is the size of the guidebook, okay? With all the information we have, we would fill about 6 binders this size. So what we decided to do was put the very basic information that our employees and our contractors needed to stay safe in this guide. And that's something they could carry with them when they're clearing snow, when they're training, doing all that stuff. And then we have a separate booklet which includes the appendices and the upgraded training we give each year, and, you know, the reviews of the safety meetings we have and how we implement those. So the actual guide itself, though, is this. And we implemented this guide in 2016. And we've had a few challenges, but the reality is the guide has allowed us to operate, construct, maintain much more efficiently, quicker, and faster, dealing with the issues we have with warming, climate change, shorter winter road seasons, more problematic winter road seasons. Okay, so basically, a standard of ice construction practices we were Department of Transportation, and then in April, amalgamated into what we call now the Department of Infrastructure. So there might slip out Department of Transportation a couple times still, but we are Department of Infrastructure. It enabled us to provide consistent and best practices across the department, so across all our regions, not just in the North Slave. Our priority, of course, is safety and due diligence, and it allows us, which is most important now, flexible, controlled, and permissive framework. Okay, so we might have been accused in the past of having a guide and then maybe stretching some of the pages on that guide to accomplish the things we needed to, which, of course, if anything ever went wrong, would be very problematic for our department. Now we have a flexible, permissible framework in how to do that. Okay, so for our operations of our winter roads, we've got three stages: a pre-construction phase, a construction phase, and an operational phase. And those are pretty self-explanatory, okay? When we're constructing, okay, basically we're constructing an ice sheet on floating water, right? So we're constructing something that's never really meant to be constructed, you know? When we do that, we need to recognize that the ice sheet deflects and bends under load, that if we're not cautious and we don't do things right and proper and monitor them and have our controls and checks and balances in place, there is the potential for equipment to break through, okay? And when we implement our safety program and our rules and checks and balances, it's implemented with the requirement and the need to protect that integrity, right? So if we go back to the access roads or the winter roads to our communities, if sometime from construction to supply to shutting down, if that ice sheet breaks or fails or we damage it, we risk not resupplying to the community. And what a lot of people don't recognize or realize is that most of our resupply doesn't happen until the very last week or 2 weeks of our winter road season. Why? Because we're trying to build ice the whole time to be most efficient to get the heaviest loads in the quickest amount of time, right? So if you're wanting fuel to your community or you're wanting to build a house and bring supplies in, you don't want to bring in half loads in February. You want to bring in full loads or even exception loads in March, right? There's a risk with that too, though. You wait too long, there's an anomaly, something happens, and you might lose that window and have to wait another year. So, okay. Stresses on ice depend on several things. Certainly one of them is weight of your load. So we need to calculate and know the weights of our loads all the time when our loads are going up there. The thickness of the ice, okay, to determine how much load we can safely haul on that ice. Speed, and a lot of people don't really understand that aspect of speed. When you're traveling, it's what they call a critical mass. And the critical mass isn't the same all the time. It depends on your percentage of ice thickness. It depends on the critical mass will depend on, if you've got half a meter of ice, it'll be a lot different than if you have a meter of ice. I guess is the way I'm trying to say that, okay? It'll depend on how many loads you have in a row and a whole bunch of other parameters. So speed is a big item. And for argument's sake, with winter roads, the slower you go on ice, the better, okay? So all these shows that we watch where the trucker gets out there, looks at the ice and gets back in and says, let's go, you know, that's for Hollywood. Because that trucker that says, let's go, potentially breaks up the ice for the guy behind him who falls or goes through. So invariably, the slower you go, and when we're really on the high end of our extreme load limits, we'll knock the trucks down to 10 kilometers an hour, okay? For any of us that drive the highway, try doing 10 kilometers an hour for 400 kilometers. Yes. The problem with that is cruise control does not let you go 10 kilometers an hour, right? You need about 15 to get up there. Our normal operating speeds with our heavy trucks on our roads are about 25 kilometers an hour. But there are extreme cases where we'll slow them right down to 10. So, okay, and then separation of loads as they go. When we're talking about ice, there's several different types of ice. When we're doing weight calculations for ice, basically we're calling it blue ice or clear blue ice, and that's what you're seeing here, okay? Yeah, you're seeing cracks, that's a normal consistency of ice. But you want it, on most lakes, you want it to be a clear or clearish blue color, and on rivers, you get a little bit different consistency, but sort of same idea. So all the calculations, the design specs we have are considered to be clear blue ice. Overflow ice, ice that's been formed in a wind and it's all kind of shattered in that. We'll sometimes drop our load calculations on them a little bit, just for that reason. No different than a highway, right, where we have solid compaction versus weight reductions and stuff like that when wet and moist. Okay. There's occasionally we have, so you can imagine on 470-something kilometers of winter road that we have sections that aren't quite as thick as we would like them to be versus the rest. We don't have the budget, the ability, or the time to flood all of our winter roads, okay? We'll flood rivers because they're relatively short crossings, or a kilometer or less, and we'll flood short sections where, on maybe a 300-kilometer winter road, you have 3 kilometers that are holding you up from a substantial weight increase. So then we'll send flood crews out for that. And over the years, there's been a fair amount of discussion about flooding and the integrity of flooded ice and those types of things. And what our engineers have determined is that as long as the floods are done appropriately, that there isn't too much snow and air and that mixed in with it, that our weight calculations would be the same on flooded ice as they are on natural ice, okay? Here's sort of a picture, and what I forgot to mention at the beginning, I was on the front slide, is that the ice engineering company we had assist us with putting this guide together is called Norex Ice Engineering. And at the very front of my slide, I put their name at the bottom below mine. We've borrowed a couple slides from them and their presentation, so this is one of those slides. So credit goes to Norex for this one. Basically, you can see a truck going across the ice. You can see the natural deflection in the ice, which is normal, and you see very little disruption in front and very little disruption behind. Now you've got the same truck moving faster. So we talked about speed and speed not being healthy for the ice, okay? And what's happening is this truck now is pushing a wave, okay? Resonating wave through the ice in front of him, and he's leaving a wave behind him, okay? When we get to what's called that critical mass, depending on the speed of the truck, the thickness of the ice, the weight of the truck, the depth of the water, where there's a rock or a shoreline, all those kind of things, these factors all come into play. And as that guy gets close to a rock, or as he gets close to the shoreline, those waves, that pressure has nowhere to go, right? So it pushes up against the shoreline, can go nowhere, or pushes up against the rock and reflects back. And that's when we have problems. That's when the ice breaks up and you have damage. And those pictures of trucks going through the ice on ice road truckers is right there. Any question?
Just because of the damage that can happen from this, you must have a lot of enforcement personnel out there that have to watch the speed of the trucks, do you? And pretty serious consequences in place if they get caught?
We do, in taking into account though, you know, we have a very limited resources available to us to cover all of that ice at the same time. So we talked a little bit at the beginning of the presentation about the joint venture and, you know, the controls and measures and what they have in place. When we get a little bit further into this session, we'll show some ice-bearing capacities that we have. And what happens is, as we allow the loads to get heavier and heavier on the amount of ice that we have, we'll put more controls and measures in place. So being government, we want a relatively large safety factor, okay? So under normal circumstances, the loads that we allow those trucks to run on, okay, and the amount of ice we have more ice than we need for the loads to run on. So it's still critical concern to us, but we don't have someone on each lake watching a truck to make sure that they go the right speed. We'll have highway patrol, we'll have RCMP, we'll have our own maintenance people out there monitoring. And funny enough, you know, the communities now are becoming quite educated and they understand the importance of this. So more often than not, I hate to admit it, that we will get a call from one of the community members saying, hey, you know what, we were out there and this truck passed me, or it was coming down the lake really fast. We have only a limited amount of trucking companies that run on the ice. We'll call up one of their safety managers and we've had drivers fired, you know, right away for it. The ice trucking, ice construction industry, you know, for all the kilometers that we put on, it's a relatively small industry, and they understand that importance, you know. I think last year we had a complaint about one of the fuel truck drivers going north towards Gamity. He made it back to Highway 3, a vehicle picked him up, and he was let go, just like that, you know. Now, all our complaints aren't valid, but certainly we try to keep on top of that. And then as we get into stretching the envelope of letting heavier loads on thinner ice, then we have more controls and measures in place ourselves. Is that answer? Okay. Okay, so separate from driving on ice, there's this issue of parking on ice or potentially stationary loads on ice, okay? So the calculation is ice is flexible, but it only flexes for so long. So what happens is the calculations we have is for a specific load or a specific group of loads to travel across the ice at an approximate specific speed and move on, not to sit out there and park for an extended period of time. So the general rule of thumb is 2 hours, okay? So for as far as operating practices go, none of our truckers or none of our heavy equipment are allowed to stop and park on the ice. No napping, no sleeping, none of that. The reality is, yes, sometimes something breaks down and we have to recover it. 2 hours, when you're at our max threshold, is acceptable. After 2 hours, we're having to become really cautious, and you run into the issue of the ice starting to fatigue and break. Okay, here's a deflection chart. This again was done up by Norex. It shows thickness of ice, or thickness of deflection, and it shows minutes on the ice. And what you can see is this particular load in this spot is sitting here is fine, and as he's sitting here longer and longer and longer, you know, you're running into that 150, 200 minute time frame. You can see how that deflection is going, right? And then about 250, she's going really quick. And on this particular graph, at 300 and about 30 minutes, he went through. Okay. Prime example of that was the winter of 2016. Okay. We've had challenges like we discussed before about our weather not being normal or inclement or whatever you want to call it, global warming. We have houseboaters out on the back bay, which probably most of you have seen or will see in the next couple of days. And one gentleman decided that he was comfortable with the ice thickness they had, and they drove out to his home there and parked out in front of his place and went to bed and got in the morning, his truck was gone. Sounds funny, but he didn't, you know. Now, I'm certain a couple of his neighbors might have said, hey, Jimmy, I'm not sure your truck should really be out here, but, you know, it's one of those rare examples where they actually lost a vehicle. Parked it, it was fine, and the ice fatigued overnight and went through. Okay, ice has cracks in it. It naturally has cracks in it, and then, of course, it has some cracks that we don't particularly want, and this happens to be one of them. Primary reason, you can see the crack all running here. Primary reason for this particular cracking is snow load on the banks, okay? When we get into construction later, we'll talk a bit more about it, but what you want to do when you construct a road is construct it in manageable sections to full width, right? You don't want to construct, and for years and years and years, our contractors constructed 20, 30 miles, 10 meters wide. Then they come back, when they're all done, they get their progress payment to get to the mine, or the progress payment to get to wherever they're going to, then they come back and start widening it out. Well, the problem is that now you've got a 10-meter wide section that has lots of ice because it's got no insulation, it's freezing really well, and every time you drive back and forth on it, you hairline crack it, it heals, and it produces more ice, okay? As soon as they started plowing it wider, they lost all their thickness. So they had no integrity in the road because they only had thick ice on a center line, not on the rest of the driving surfaces, okay? So what we do now is we construct a road to full width in manageable sections, in 1 day or 2 days to get to full width. Most of our roads range around that 30 meters wide. The Detta road, we get a lot of tourists on that, so we go a bit wider, about 50 meters wide on that. What you can see here is you've got the snow load on the edge of the bank. You've got the center of the road growing substantially quicker than the edge. So you've got ice growing here and snow load here, and those banks will crack sometimes, and that's what that is. Invariably, what happens is those banks will crack, water will bleed up through them, water will reheal, reform the crack, and you're good to go again. In the meantime, though, that's quite a substantial risk. So our snow equipment, plow equipment, and all that won't go outside those cracks. And that brings us to monitoring our roads and making sure that we have staff and people out there watching for that type of stuff. And then, of course, coning it, sectioning it off, or doing whatever we have to do to ensure that the public or our own contractors or our own staff don't drive on those, right? Other cracking, okay, so ice shrinks when it gets cold. A lot of people don't realize that. Ice actually shrinks. So this is just from the cold down to the center of the road and ice shrinking. Not necessarily a concern unless it goes through more than about 50% of the ice sheet. And in most cases, water at some point will bleed back up and or we'll send maintenance crews out to water them and away they go. This type of cracking here, though, very normal for us during the wintertime. And as you get close to the end of the heavy haul, you get more and more of that cracking, just from the stresses of the trucks and the weight and that. This here is the opposite of that. So these are pressure ridges that are built. And I'm sure most of you have seen fairly substantial pressure ridges going up and down lakes. They can go for miles and miles. And they're problematic for us, of course, because quite often we have trouble safely getting across them. You know, they might have less ice, more ice, broken up, types of issues like that. Okay. And then this is kind of an example we talked about already, fatigue cracking. That's just a load sitting there for too long. You can see how we're getting circumferential cracks, we're getting radial cracks, and finally that truck's going to go through. Okay. So for ice, we have levels of confidence in the integrity of the ice sheet, effective thickness of the ice sheet, and accuracy of loading. Okay. Those three things. We need to know what our loads are and how much they weigh. We need to know how thick our ice is, and we need to know the ice is fairly good quality ice. Does that make sense? Okay, and then for as far as weights go, ideally we want to have all our equipment weighed, right, scaled, and we call an operational tare weight. So that means the weight that equipment's going to be when it's out there operating, whether it's got an attachment on it or non-attachment, whatever that is. And then we also want to know a GVW so that you know how much that truck will carry when it's fully loaded, kind of thing. Measuring ice thicknesses, you know, the old adage of taking an auger and drilling through holes worked. There's new technologies now, and our government believes strongly now in ground penetrating radar, GPR, and it sends an electrical pulse through the ice to the water, reflects back, and gives us very accurate information, very accurate data. Technology has been around for pretty close to 20 years. User-friendly software's only been around 5 or 6 years. So we work very close with a manufacturer in Canada. They come up each year to us in the North Slave and do ice testing, research and development, and come back and try to improve their programs every year. We want to make sure that we have a safe distance between vehicles, so those two visiting ways we're talking about aren't too close together. And we want to make sure that our maintenance is on top of the ice surfaces, checking them, fixing them when you need to. As you're aware, primary construction tool for ice is water, right? As long as you got cold temperatures and water, you can pretty much fix over time, if you got enough time, any issue that happens on the ice. Okay, issues of operating on the ice, of course, is they're moving loads, multiple loads, frequently repeating loads, and parked and stationary loads. So we've discussed most of these already. As you get more and more use and heavier loads, the ice is going to be stressed more and more, no different than any other highway system. So you want to monitor it closer and closer. Okay, again, we talked about weights. Ideally, you want scaled weights. In some of our communities, we're not able to get scaled weights, so they'll use manufacturer specs on some of the stuff. We have access to Highway Patrol, so we'll quite often ask Highway Patrol to take out portable scales and weigh equipment so that we know what it does. And then we'll use Highway Patrol's portable scales for weighing commercial stuff on the road if we're concerned about a weight of something that's on the road. Okay. Again, monitoring vehicles that they're not too close together, and at times we'll send our own staff or Highway Patrol out to enforce safety rules, because there's always someone in the group that wants to stretch that a little bit, right? Someone doesn't really think that going 20 kilometers an hour makes a difference. It might not make a difference for his particular load, it'll make a difference for the 600 loads coming after him. So here we get to calculations for ice bearing capacity, okay? So P equals AH squared, fairly simple mathematical equation. P being ice bearing capacity in metric kilograms, H being the thickness of your ice in centimeters, and A being a value assigned to that calculation. For normal operating procedures in the government of Northwest Territories, we use a value of 4, okay? That's a proven number on Gold's formula over several years, and that leaves a substantial safety margin in place, okay? So we talked about controls and measures, we talked about having people out there monitoring. Probably our best control and measure is that value right there, 4. Leaves a fair amount of safety and tolerance, okay? So for example, if the load, I shouldn't say this, but if the load's slightly heavier than it's supposed to be, we'll probably be okay. If the vehicle's going slightly faster than it's supposed to be, we have that little bit of buffer in that value of 4. As you increase that value, your buffer gets less and less, right? So standard scenario, we go out and we measure the ice, we have 50 centimeters, 50 times 50 is 2,500, times it by that A value of 4, okay? Which means we assume, following our controls and measures and regulations and the ice is good quality and all that other good stuff, that 50 centimeters can carry about 10,000 kg, okay? That calculation will work for any thickness of ice you have. Times the height squared times the consistent value of whatever you want to use. We're using 4 in this case, and that'll give you the ice bearing capacity. Any questions on that? Okay. In saying that, when we first go out, we'll do some drilling, but we want to profile if at all possible. We're using new technologies, not necessarily new, I guess, but we try and use either semi-submersible or a piece of equipment that float when we first go out on the ice. So that's what we have there. And we got a little profile unit you can see actually in the back of that machine right there. And it's a computer antenna that sends a 5 megahertz wave or signal into the ice, back up, reads it, and then allows us now to see it on a laptop computer. Okay. Should mention on that, manual drilling is still required, though. It's required to calibrate the computer on that unit, and it's also required to ensure that the ice we're in is good quality ice versus fractured ice or other types of things. So there are times you need to visibly see that. They are working on new technologies right now that might take some of that into account, but at this point in time, they can't yet, or not reliably. This is what would be a normal GPR line. You can see Yellowknife here, and you can see the community of data there. So this is about 6.2 clicks. And then you can manipulate this on a Windows program however you want to. But what it really does is it identifies the thin spots at a glance. So anything that's yellow or red is thin, okay? And you can set the parameters of what you want thin to be when you go out there. Gives you the ability to share the information quickly and easily. And it works really well for maintenance crews because if I need to, I can send a maintenance crew to that red spot right there, give them within a few meters of exactly where that spot is, and they can do flooding to increase our ice thickness there. Okay, and then separate from that, it gives you some very general information without going into the program. And in that particular spot that was red that I'm worried about, I can zoom in on, and it'll tell me, Google Earth is a wonderful program, but it won't pick up all the spots that our actually profile unit shoots. So it'll average maybe anywhere from 3 to 20 spots, roll them into one dot, and then tell us the average ice thickness, the min and max right there. We don't use this for determining our minimum ice thickness. We use the program that's more detailed that tells us that. What is nice about this, though, is it's quick, fast, something you can send on to a manager or a supervisor or to a maintenance guy that has to go out to location and do some work or do a check. Quick, fast, easy, works really well. And we've only been able to do this for about 5 years now. Okay, so we talked about different levels, and we talked about that A value of 4. So what the new guides allowed us to do now is go into what's called a routine, so a normal operating cycle, and then we can go into, if we need to, an enhanced, and in some cases, an acute range. And as you go from normal to enhanced to acute, then we put more controls and measures in place, right? We'll check the ice more often, we'll have more monitoring going on, et cetera, et cetera. Within DOT, or within Department of Infrastructure, we stay within the routine and the enhanced modes, okay? Once we get out of the enhanced mode to the acute, we'll then go to an ice engineering company and go away from a single point load that Gold's formula is, instead go to a multi-point load spread over a certain distance, and those calculations will be engineered. So to put it simply, depending on whether we're doing construction or maintenance, depending on some other scenarios, we'll use an A value of 4 for routine, we'll use an A value of 5, up to a maximum of 6. Usually 5.5 is as far as we'll go on the enhanced, and then once we get above 6, that's it, we'll go straight to engineered loads. And none of our crews have the ability to go to enhanced or acute without a sign off from our superintendent. So we have controls and measures in place for that. Okay, and then now you're looking at a chart here. So our normal operations, right? Less resources, less robust Q&A, passive controls, more conservative. As we go up the chart, which now allows us, so if we've got 300 kilometers of road and we're trying to get a heavy load into one community, maybe we only got a stretch of 4 kilometers that's problematic for us that we can't get ice to grow on, or we haven't been able to flood enough to get it to grow on. We can go into the enhanced or the acute operations mode for those 4 kilometers. We can have staff staged out there, we can have highway patrol out there, you know, we can do additional ice checks closer together, all those kind of things for that short section, and then go back to normal operations outside that section. That's the big plus of this new guide. It allows us to go to those areas legitimately, following a process, and get our loads into the communities when we need to. And with more problematic times on the ice and warmer and warmer temperatures, we're looking at probably having to do this more and more often to be able to do the same things we could do 10, 15 years ago. Okay, I'll speed it up just a little bit. So for our staff, this is sort of pre-construction, right? Routine mode there, tells us kind of what our staff have to do, and enhanced. Gives us nothing on acute because on pre-construction, we're not going to take any risks. We're not going to stretch our envelope that far to go to the acute range yet. We're just setting up for construction, right? We're sending profilers out, checking on ice, and get ready to send out plow equipment. This one here is for, we've got separate safe work practices. This one's for working on a river, which has more controls and measures in place than working on a lake, just because you got moving water and current. But now that we're doing maintenance or running operations on a river, we have the routine mode, the enhanced, and the acute. And as you can see, in the acute mode, we'll go out there, get information, and provide that information to an experienced ice engineer, and they'll do a stress analysis on us and let us know whether that loads can go or not. And anytime we go to the acute mode, I shouldn't say anytime, majority of the time we go to an acute mode, it's a customer or client wanting to get a load in or out, so then they will pay for that engineering recommendation. And we won't allow them to go unless we have that recommendation in our hands. So we control the commercial traffic. Regardless of all the technologies we have, inspections are important, critical, crucial, right? They're making changes to our software programs where this type of stuff will show up, but all the ducks have to be in a row for that. You know, the person operating the GPR machine has to be paying attention, nobody's looking at, all those kind of things. The short version is we require our staff to go out and do regular visual checks, okay? And nothing happens unless it's on paper, so. We talked already about speed limits and spacing, inspections, signage and enforcement, staff training we've discussed for the last 30 minutes or more, and monitoring and reporting, okay? By law, we have to have, and workers' compensation requirements and our own, we have to maintain log books, we have to maintain copies of the GPR data files, inspection reports. We do as much as we can broadcasting to the public because then they can start planning their loads for the commercial loads, the public can travel. It's important for people getting out of the communities. We do Twitter updates now. Don't think we're doing it on Facebook, but we do Twitter and internet updates, as well as winter road entered signage when they go on the roads. And then we have that authorization process for when we go from normal operations to enhanced and acute. Okay, we talked about changing that A value. So we've gone through the book now, and then the appendices are live documents that we'll continue to work with over time. Some of them were not even absolutely completed yet, but in the appendices, A, B, and C, they have the different loading charts. So one of the risks we talked at the very beginning about is, you know, having the public be aware of everything we do, is you could potentially, somebody from the public say, hey, I'm going to use an A value of 6, right? So if you've got 100 centimeters and you're using an A value of 4, that load's good for 40,000 kg. If you use an A value of 6, that road's suddenly good now for 60,000 kg, right? That's a substantial difference. If you don't keep those controls and measures in place, you can see the risk. So we talked about speeding, we talked about these other things. When we're going up to that level, we have all those controls and measures there, monitoring and making sure. Okay, the other appendices we have is Safety Act. A lot of these are linked to work WSCC because our department doesn't want to conflict with WSCC. So we have those guidelines, worker guidelines, training guidelines are ours internal, safe work practices are ours internal. Safe work procedures on initial snow clearing, inspections, accident reporting, winter road closure at the end of the year. The public wants to understand the process we use for that. So we have those. And then we explain a little bit more GPR because a lot of people aren't that familiar with GPR. Okay, this is what the GPR screen actually looks like when our guys are out profiling. And as you can see here, the minimum ice at that point is about 71 centimeters. But you can see the variations in the ice, okay? A lot of people think ice is level. It's not. It just changes consistently all over, and sometimes for no valid reason. Okay, we want to make sure we have skilled and qualified field operations, and make sure we have skilled and qualified people to evaluate that information that they have. Okay, so we're back to the exact same things we talked about before. Confidence in ice integrity, confidence in ice thickness, and confidence in loading conditions. Okay, we've talked about public safety, community resupply, environmental regulations and issues, risks, and communication. Okay, that's the end of the safety portion of the presentation. I'm running a little shy on time. I have a construction portion if we want to look at, but before we go there, is there any questions on the safety side of it? Yes, sir.
Just one, you mentioned that a truck really can't sit still for any more than 2 hours. And you mentioned you have one stretch of road that's about 400 kilometers, so that's 40 hours. So do these trucks run team, or what do we do about the safety about a driver? You wouldn't want somebody driving 40 hours. One, it's beyond the hours of service laws. Two, I think they'd get tired, so.
Yeah, correct. Well, to clarify, we don't want any vehicle sitting on a sheet of ice longer than 2 hours. And you know, at the A value of 4, he could probably sit there, and I gotta be careful saying this, but he could probably sit there for a couple days. When you get close to A value of 6, that's a whole different story, okay? So the recommendation is no longer than 2 hours. But your primary question is, you know, where do they stop? What do they do? Well, remember we talked about 60% lakes, 40% land, depending on which community we're going to. Our longest lake that we're running the guys on is probably about 38 clicks, and the rest of them are shorter. So when they get to the portages, we'll find spots for them and plow kind of triple lanes and have areas for them to pull off. So, works good. Okay, I think I'm going to flip over to this one quick. Okay, I'll go through this a little bit quicker because I know we're running short on time. And it doesn't really require a lot of explanation, I don't think. This is the fun part. Windrow construction, right? We went through the staff training and all that kind of stuff. That was the fun part. First couple slides, we talk again about requirement manual training. We've gone through most of that. We talked about our new guide, okay? We talked about not only the requirement for annual training and sign-off sheets and having it documented and keeping workers' compensation happy and those types of things, but also the reality now of going out and going to work. The safe work practices we have for the crews going out, checking the ice and starting to construct, starting to plow, right? Got to have daily table block meetings, minimum weekly safety meetings, and anytime there's a concern or issue, everything shuts down. We go through it with the supervisors. If supervisors can't fix the problem or are uncomfortable with it, they'll get a hold of myself or someone else. We look at it and then move forward, okay? This is the normal safety gear our crews have. During initial construction, every one of our contractors and our own staff are required to wear a floater suit. Been proven time and time again, they save people's lives, okay? And that's just a throw rope. This is a style of a window breaker, seatbelt cutter. These are picks that the guys can use that are wrapped in their suit in case for some reason they go through. They can pull themselves out of the ice. And then these are just other safety gear that we have for them. Okay, so we talk about the requirement for meetings, safety meetings, making sure we have the proper safety gear, those types of things. Identifying the supervisor, ensuring we log in and log off the ice at each shift. Making sure the shift supervisors communicate back and forth. We want no surprises when our crews are out there, okay? Talk about the requirement. Each piece of equipment we have is required to have the operational tare weight and gross weight on both the outside of the vehicle and the inside of the vehicle. We had a supervisor who was given a week off without pay for not having those weights on his equipment. Our drivers have to know what their equipment weighs, and they have to know the ice thickness, okay? Talking about training and training records, and everybody has to ensure that they have had training and are qualified before they're out and operating stuff, right from the laborer to the supervisor, okay? We talk about making sure the public is safe while we're working on the road. We've got to have all our road close signs in place. The public has to know that road is not open. There's so many liabilities that go with that. Because when we're out there constructing, we know what ice thickness there is, and we know what our vehicles weigh. The public is just interested. They just want to get out early, right? Okay. We talked about using GPR for profiling when we first go out in the ice. This is a job I helped on out of Sigachik, close to Inuvik. No profiler is going to go over that, right? It's not going to. So there's still times we have to manually core. And you can see guys here with tie-off ropes and steel bars checking to make sure there's no holes in the river. This is on the Mackenzie River, okay? And then these guys are tied off and they're going out. Okay, when we're doing manual coring, right, you'd think measuring the ice is easy. It is, but there's a process to it. And we want to use a measuring stick of some type with a foot or a piece on the bottom that goes across the ice, okay, and holds it there. So you got something to push down and pull up on and measure it, right? There's so many times people take a tape measure and, you know, try to guess what it is or hook it on the side. That's not the way to do it, okay? Here we go. We use different equipment. This one here happens to be a machine that's semi-submersible, so if the guys go through, it'll float. Okay, and we're going out initial ice checks doing GPR. Okay, this is a GPR unit in the back of that sleigh too. In the last few years, different companies have come out. This one has to be a Kobeck system with a drill, just a little 2-inch auger. Mounts on an electric drill. It's fast and easy. You don't have to have carry gas and try and get your auger to start. Push it through the ice. It's got a tape measure. I don't have one here. It's got a tape measure with a breakable bar on the bottom. So when you push it through and pull up, it locks on the bottom of the ice, and you give it a little tug, and then it comes up again. Quick, fast, efficient. Carry the battery in your truck, and away you go. Okay, so we want to make sure that when we're out working on the ice, that we pick an alignment, we profile that alignment, and then nobody's allowed outside that alignment, right? Now, whether you're using the tracks for the machine, or they're putting stakes out, or whatever it is, once that alignment's picked, nobody's allowed outside of it again to work unless we do more profiling. Right? Because we don't know what the ice thickness is outside that alignment. Only the stuff that's in the alignment. And we document all that. Okay? Again, now we're going out and starting to work. These guys have a plow truck right behind them. This is one of our contractors' units. It's just a regular Jeep with hydraulics that they put on it and 2 outriggers. So when he's out there working, if something happens to go wrong, the assumption is those outriggers will catch on the ice. If he happens to break right through, the engineering on that says that it'll float. So more and more importance for putting on this kind of stuff now because we're getting more and more anomalies out on the ice. We're not getting consistent ice sheets. As I indicated, the start of our Talicho Winter Roads is 100 kilometers from Yellowknife, and from there we go to 3 different communities. One is 300 kilometers away, the other one's a different direction, 200 kilometers away. We have mobile construction camps. That way their travel times aren't near as much. Okay? Standard camp setup. You can see small light trailers so we can get them across the ice quicker. Okay? So now, testing's done, plowing started. You can see some markers. It's hard to see out there in the snow there, and one further up here. That's the center of the alignment that we want to stay on, and our crews go to work. Okay? Depending on where we are and what we have, our own Department Infrastructure crews, we construct and maintain the Deta Road, we maintain the Talicho roads, and then we have one road that we have a contractor construct and maintain. For maintaining our roads, I have access to 2 highways camps, about 60 pieces of equipment total between Yellowknife and Etchico. So we can ramp things and move things pretty quick when we need to. And then of course, ideal conditions aren't always ideal for getting heavy equipment across, so this is some typhoon flooding. Looks a little funny, but either way, he is flooding there. And they'll flood short sections. And then on rivers, we'll use what they call technology of spray ice. So although the machines are old, it's a technology where you take water and you spray it in the air at the right temperature, at the right angle, with the right nozzle on it to break the water droplets up, and it lands as ice. It doesn't land as water. You can manufacture, around 30 below, you can manufacture up to 6 inches a day in ideal conditions. If you mess up and you put too much water or not enough water, makes snow, too much water, makes a flood, you can hold a crew up for 4 or 5 days. Okay, something as simple as a drag behind a halftime. Ice doesn't always freeze level, right? You get wave action and all that kind of stuff. Before we had the public out, we couldn't have a lot of weight out there. We had a drag being pulled behind a pickup truck. It works. It levels snow off on the ice, breaks ice tops off, away it goes. Again, now we're getting ready for heavier equipment, so we've got a couple different profile units out there checking the ice. That grader happened to be waiting on this lake to get across when this guy was there to profile. And again, drags are really popular with us, smooths the road out, So we'll pull drags behind our plow equipment quite often. There's a couple pictures of, this is a tri-drive unit there, and this is just one of our own plow trucks, right? So what you want to do is, once you start clearing, is get that snow off while it's still soft, fairly quickly and done. You don't want to go back into something and plow it again once you've broken the snow up. It's no different than you walking to your house or up the steps for a week before you shovel, right? Makes a big difference. Snow cats are really popular. This particular snow cat, they're good for pulling snow in from the sides. Our regulators require us to have a minimum of 10 centimeter snow coverage on our portages. So he'll push snow out, drag it, water, and then pull snow back in and continue to drag it. Okay, same thing. They're using another grader with a small grader with a drag, a loader with a drag. We've got to make sure we follow all our regulations. So DFO says we have to use screens with holes in them no larger than 2.54 millimeters, fish protection. So they're problematic quite often in the real cold, but we carry Tiger Torch and heat them up and use them there. Our contractors are going to new technologies. So this is actually a watering vehicle that they can put a plow on, but it's got big flotation tires on it. So it's not running up the land, and they can carry a lot more water. Okay. Our road's open to the one community. There tends to always be a lineup of vehicles waiting there. I mean, if you were landlocked in a community for 10 months or 10 and a half months, we're waiting to go, right? Even just to go for a drive, right? We're waiting to go. So, okay. A lot of people don't understand how fast our roads can blow in and be dangerous and problematic, right? Years ago, anybody that traveled a winter road had a good old Chevy or a good old Ford or maybe a Dodge truck, 4x4 or snowmobile in the back, and away we went. Now we're having people going up there in Golfs, you know, Honda Civics, no safety gear. You're laughing, but it's true, you know, it really is. And you're looking at these people and you're shaking your head because they're out there and they're stuck in the snowbank and they're in running shoes, right? That's it. I'm getting the evil look, so I better hurry up here, I think. Just talking about cracks, normal cracking and maintenance we have on them. Again, in the maintenance stage, we're watering, we're flooding some sections by hand. I apologize for going quick, but I think I'm just out of time. Again, these are our maintenance crews. What's critically for us is during the first third of the winter road season is when we build the majority of our ice, right? As the ice sheets get thicker and thicker, it grows slower and slower. So you want no insulation on your ice sheet at the beginning of the season, right? Every time it snows, we want to be out there plowing. In the end of March, if I have 6 inches of snow on the lake, not a big deal as long as people aren't getting stuck. I got 6 inches of snow on the lake for a week in end of January, early February. I just lost 4 or 5 inches of ice growth. Add that up over a few times and it makes a big difference. This sort of stuff that I wouldn't normally show off, but it's a reality. You know, portages get beat up, so we want to get working on them. Overflow, we have lots of trouble with, so we're working on an overflow patch there. Here's our water trucks out, base strengthening, picking up with the portages again. A lot of people don't think about portages being problematic in a storm. Well, be out there in a little two-wheel drive car and drive on that portage, right? Like you're gonna have a hard time getting through. So make sure we got our safety gear with us when we travel. Watch out for hazards, people working, water trucks, steep hills, wildlife, right? One of the great things about working on a winter road, there's not a lot of traffic up there, especially when you're constructing. You have those opportunities to see wildlife. Make sure, yeah, you watch for other traffic, be considerate, right? Don't go 50 miles an hour around a corner with your back trailer sliding sideways up in the ditch. Good for TV, it's not good for people on the road, right? Here's some banks you can see. We talked about the cracking in the banks. The waters come up, when that re-heals, it'll be good, it'll be strong again. But you gotta give it that time to re-heal, okay? Again, with climate change, there's so many locations now that we're getting this type of overflow problem where it creeps in. You gotta send a grader out or you send a loader out. And then we've had forest fires in the North Slave region for a while here. So that changes the water flow patterns. You know, the vegetation isn't holding the water like it used to. So all those new kind of things that are challenges we're having. Again, some areas, just because of the reality, we're down to one lane, so we want to be cautious of that. Some fairly steep hills, other obstacles, rocks, and that we want to mark out for the public. This is a new one, okay? These types of fingering going on, stink holes, rat holes, whatever we call them, we've always had them. We've never had them like we've had in the last 5 to 7 years, okay? You drive up and down the Windrows Road now, Our contractors quite often won't plow at night anymore because these things are just all over the place. This, my counterparts here, Jamie, this is a section of road we opened. This road's been open for almost 6 weeks. And we were driving by one day and just seen a color that looked kind of wrong. So we went with a stick and broke it up. He's got a 4-foot piece of lath stick stuck through the ice there. It's open water, it's about 3 feet wide, and it goes down about 20 feet, okay? So how is it possible that a winter road that just had a heavy grader go over it or a heavy piece of equipment go over it, a couple weeks before, has that? It's our changing environment, it's gases from vegetation gases or gases from the earth or something. That stick right there behind him has 65 centimeters, and that stick has almost 80 centimeters waves. But there's actual open water there where he is. Okay. Again, this is the summer of 2015. We were about 2/3 of the way through community resupply. It warmed up for a couple of days. We had some really strange stuff go on, and our primary lake, 35 kilometers long, and the South Inlet Road network broke up. Just had cracks all over the place. Water pumping out of it. So we put extra controls and measures in place. We brought highway patrol out, monitored the road 24/7 with our own staff, ensured people slowed down, and we're still able to get resupply done. So that's the changing environment we're working in now. Okay? There's always an issue. No matter what you do or how careful you are, there's always a risk. Okay? This particular day, during construction, snowcat operator's got 30 years experience. Spent his whole life building winter roads. Okay? These cones here are the edge of the road alignment. Okay? We've got chains from here to there, that's about 6 feet, that chain is, from there to there, where we're there in solid ice. We talked about those anomalies of stink holes or fingering and that kind of stuff. This operator made his pass, was turning here to head back south again. Tracks are wide on it, just happened to go outside the marked alignment he was in, bang, went through. It's critically important that once we profile, everybody stays within that alignment. One of the mitigating options we've gone to in the last few years is nighttime travel to save our winter roads, to save our portages. We're getting so much solar load during the daytime now, and the sun's getting so much stronger, even at -5, -8. Our portages are melting up on us during the middle of the day and heating up. So we'll run heavy traffic from 10 at night until 10 in the morning, and close from 10 in the morning to 10 at night. Makes a big difference. We wouldn't have gotten our resupplies done in the last couple of years if we hadn't done that. And that was very problematic for the communities originally to buy into, but now that they realize that it keeps the roads open longer, they get their resupplies done, their last loads in, we have buy-in from the communities on it too. So this was second last day of resupply. One of our lakes, overflow come in, the water started giving up. We had no place to push the water to. You're probably 18 inches to 2 feet to the front grill of that truck. It's coming back. And of course, you've got a couple members of the community waiting there to see where the truck's going to go through before. And this is one of our company vehicles going through. Okay. This was closing day of the road, right? When you're out there and our front grill and bumpers making a wave in front of you, it's time to close the road. Right? So, these two are kind of for entertainment, but there is a process in place to close the roads. There is a lot of knowledge and ability out there to understand and know when that time comes, and when it comes, that's it. We close the road. We're done. Okay, and then in most cases, we try and barricade a road off. We can't always, because a lot of times the communities furthest up north, their road sections are still good. They'll still get wood, and they'll still get stuff like that from that end, but we'll close it on the south end, so vehicles can't travel. Anybody that was down dead road, somebody says they noticed signs on our dead road access. And the question is, why is there a sign there? Well, we have a liability, and if we don't have a road closed sign at the entrance to our road, we end up potentially with that. Long story short, that was a stolen car. Somebody thought they could make it disappear. They didn't realize that there was a sandbar out there before it got beat. Can't win them all. Thank you for your time. I went a little bit over, so I apologize for that. Is there any quick questions before we shut down? Thank you, everyone. Really appreciate it. Oh, I'm sorry, was there one?
With the global warming, how much on average over the last 5 years would you say have you lost out of your ice road season compared to what you had years ago?
That's a really hard one to quantify because every spring is different and every fall is different. I could put it to you another way. We've put probably 5 to 10 times more effort into keeping our roads open than we did 10 years ago, okay? So we might have closed the road, like right now, our closing dates, this year we're about 2 weeks off historic. But the only reason we can keep them open that long or get them open earlier is putting more effort into it than we did before, okay? And using new technologies, using lighter equipment, all those kind of things, where before, when I grew up, you know, I grew up here, January 1st, we go. That's it. Get in the truck, boys, we're going. No, there's no reason to check the ice. You gotta go plow it anyways. You know, that's the difference, right? So, thank you very much.
So thank you, Gary. That was quite informative, and I think you've kind of dispelled some of those Hollywood myths from ice road truckers. No, well, you did a pretty good job, so you're going to be a YouTube sensation, I can tell you that, because we are videotaping the concurrent sessions, and they'll be available on CCMTA's web channel, YouTube channel, sorry, a few weeks after the conclusion of the meeting, so you'll be receiving a link so you can go on and see the session if you want to go through the presentation again. And we're going to be breaking now for a few minutes to grab a cup of coffee and to transition to our other sessions. Our other sessions start at 2:45, and there's information in your programs for the next events. And before we leave, I would like to, on behalf of CCMTA, to provide you with a small token of our appreciation for your presentation today. Thank you very much, Gary.
Thank you very much.